Class we are going to see how to write chemical formula. All right, so the first compound that we'll take is, let's say we'll start with a much more simpler potassium chloride. Okay, now the first thing that you should remember is when you're writing a chemical formula, you need to know what are the ions present in the compound. So by looking at the name of the compound itself, you should be able to identify the ions. So potassium chloride compound will consist of potassium ion. Okay, it will have potassium ion, and it is also going to have chloride ion. Now how do we write what's the symbol for potassium ion? Now this is where you will make use of the valency chart that you have in your textbook along with the list of radicals and ions. So if you look up the chart, you will see that potassium ion is written as K plus 1. Chloride ion is written as Cl minus 1. So K is the symbol and this plus 1 and minus 1 indicate its valency. After you have identified what ions are present, you are going to start writing the chemical formula, firstly by writing the symbols of the ions. So potassium ion, the symbol is K, and chloride ion symbol is Cl. After writing the symbols, you are going to write down the valency right below the symbols. So potassium has a valency of 1. How do I know? Because I'm writing the ion as K plus 1. So from there I get to know that potassium has a valency of 1. It is monovalent. Chloride ion is also a monovalent ion. So I will write 1 under Cl. After writing these numbers, you are going to use the criss-cross method. So this method of writing the chemical formula is called criss-cross method. In this method, you are going to write the symbol of the cation, which is the positive ion, first, and then you are going to write the valency of the negative ion. So K you will write first, and then you will write the valency for chlorine at the bottom of K. Then you are going to write down the symbol of chlorine, and you are going to write down the valency of potassium at its base. Usually, if the number is 1 at the bottom, we do not tend to write that number. Just by writing the symbol indicates that there is 1 atom of potassium and there is 1 atom of chlorine. So KCl is the chemical formula for potassium chloride. Let's take potassium nitrate. Right? Potassium nitrate consists of the ions potassium ion, which is K plus 1, and you have the nitrate ion, which is written as NO3 in brackets and having an overall charge of -1. Nitrate ion over here is what we call a radical. A radical is a group of atoms together carrying a certain charge on it. Okay, so now after identifying what ions are present, what should I do? I should write down their symbols and their valency. Okay, so symbol for potassium ion is K, and the symbol for nitrate ion is NO3. Valency for potassium is 1 and nitrate ion is also 1. I will use the same criss-cross method and I will write down K first, and at its base I will write down the valency for nitrate. I will write NO3 together. Always keep NO3 inside the bracket so that it's easy for you and you do not get confused. Okay, so NO3, and at its base I am going to write 1. Again, like I said earlier, if the number is 1 at the bottom, I do not have to write that number 1. I can go ahead and write the formula as KNO3. So this is the chemical formula for potassium nitrate. I hope that is clear. We'll take is of, let's take aluminium oxide. Okay, aluminium oxide. So we are going to write down its ions. So the ions present are aluminium ion, and you have oxide ion. Aluminium ion is represented as Al3 plus, and oxide ion is written as O2 minus. The symbols are, for aluminium the symbol is Al, for oxide the symbol is O. Valency of aluminium, I have written +3, so valency of aluminium is 3 and oxygen's valency is 2. So when I write the crisscross, when I write the formula using the crisscross method, I will take the symbol of Al, and at its base I'm going to write the valency of oxide, followed by the symbol for oxide, and then finally the valency for aluminium. So the formula for aluminium oxide is Al2O3. Now it seems a little bit easier for writing the chemical formula, but nevertheless we'll practice a little bit more. This time I want to write down the chemical formula for the compound magnesium oxide. Okay, magnesium oxide. Again, the same steps I am going to repeat. So the ions present are magnesium ion and oxide ion. Magnesium ion is written as Mg plus 2 and oxide ion is written as O2 minus. Now I'm going to write down the symbol and the valency. Now symbol for magnesium is Mg and symbol for oxide is O. Valency for magnesium is 2 and valency of oxide is also 2. I'm going to go ahead and write down the formula. So Mg, and then I'm going to write down the number 2 at its base, and then I'm going to write O and write 2 at its base. Now here there's a certain thing that you need to notice, that both magnesium and oxygen have the numbers 2 at its bottom. What it means is that 2 atoms of magnesium combine with 2 atoms of oxygen. Alright, now because the numbers they have a common multiple, and if I divide both the numbers by this particular number, then I can simplify this a bit further. So the number that I can divide both 2 is by itself. If I divide both the numbers by 2, then the formula becomes Mg1O1. If the number is 1 at the base, I need not write that number 1 and the formula becomes MgO. Now it's important to understand why I have divided it. I'm dividing it to simplify the numbers. Okay, to simplify the numbers. Why am I simplifying? Because then it will help me understand how many atoms of magnesium combine with how many atoms of oxygen. Whenever you write the chemical formula, you need to simplify the numbers to the smallest whole number. Alright, and both the numbers 2 have the common multiple 2. If I divide both the numbers by 2, I get 1. 2 divided by 2 is 1, so I get the formula as Mg. Calcium sulfate. Okay, now calcium sulfate will follow the same steps. The ions present are calcium ion and you have the sulfate ion. Calcium ion is written as Ca2 plus and sulfate ion is SO4, together having a charge of -2. The symbols are Ca for calcium and SO4 for sulfate. Valency of calcium is 2 and valency for sulfate is also 2. When I write the chemical formula, I'll follow the same crisscross method, and I'm going to write down Ca first, and then followed by the valency for sulfate at its base. Then I will go ahead and write down sulfate. Make sure that you have written sulfate inside the bracket to remove any kind of confusion, and then you will write 2 at its base. Alright, now you'll notice that both calcium and sulfate have the number 2 right at the bottom. So this 2 can be simplified by dividing by the highest common factor. The highest common factor between these two numbers is the number 2 itself. So I will divide both these numbers by the highest common factor, and I'll simplify the numbers, and now I get 2 by 2 is 1, and SO4, I'll keep it inside the bracket. 2 by 2 again is 1. So I've got Ca1, I need not write it. SO4, again 1, I need not write it on the outside. So this is the formula for calcium sulfate. So it's important to know what is the highest common factor between the numbers. Alright, let's take another example. That we are going to look at is a different cation. So now you had been looking at cations, which are simple ions. I also want to solve one such radical consisting of a positive ion. So ammonium chloride. Okay, how do we write the formula for ammonium chloride? So it's the same process. The ions present are ammonium ion, and you have chloride ion. Ammonium ion is written as NH4 together carrying a charge of +1, and chloride ion has a charge of -1. The symbols of ammonium ion is NH4, that's the symbol, and chloride ion symbol is Cl. Valency of ammonium ion is 1, and chloride ion is also 1. I will go ahead and write down the formula by using the crisscross method. I'll keep NH4 together, and at its base I'm going to write down 1. Then I will write Cl, and at its base I'm going to write down the number 1, which is the valency for ammonium ion. So you've got NH4Cl. This is the formula for ammonium chloride.